In this video, we'll explore lines. Now, first thing we'll talk about is slope. And slope is helping to represent that steepness of that line. What's the rise over the run of that line as we go left to right? And when we look at that, we can use the slope formula, where we're going to subtract our y's over subtracting our x's, and that'll give us that rise over the run. If we're positive, we know we're rising as we go to the right. If we're negative, our line is lowering as we go to the right. If it's undefined, it's vertical, and that's because our x values are identical. And if it's a zero slope, it's a horizontal line because our y values are identical. So say we have these 2 points and we want to know more about this line that's being graphed. What's its slope? And what we can do is just use the 2 points we have. So I could just call either of these the first order pair or second order pair. It doesn't matter as long as I stick with it. So I'll just go in order that they show up. So y2 would be -2, y1 would be 4, x2 would be 1, x1 would be -3. And I simplify my fraction. So I get -6 over +4, that's -6/4. I simplify, that's -3/2. And I can check that. If I go down 3 over 2, down 3 over 2, down 3 over 2, I'm always ending up on the line. It's a constant rate of change. Now if I'd used the -6/4, forgot to simplify, it would still be okay, because if I go down 6 and over 4, it still puts me back onto the line because they're simplified, they're equivalent fractions. So if I want to graph and all I have is the knowledge of what is my slope and a point, I can use that to help me. I can plot the point and then use slope to create a second point to create the line. So in this case, I want to graph -2, -4. I'm going to use slope. Now a whole number is always over 1. So I need a fraction when I'm doing slope to have rise and run. So in this case, I rise 3, I run 1. And then I plot the point and draw a line through them. Here's another example. Say my slope was 0, which is a little bit different case. So I'll plot that point of 1, 3. So I'm going to rise 0 and run 1. So I'm not going to rise at all. I'm just going to run to the right 1. And I draw a line through that. And there again, horizontal line. So you can see that a slope of 0 creates that horizontal line. Now, one way that I can write my equations is using the slope-intercept form. Y equals mx plus b. M is the slope. B represents our y-intercept. Where does the graph hit the y-axis? So our y-intercept is always 0, comma, whatever that value is. So we can plot that point, use the slope, and then draw a line through the 2 points we have. So if I look at this equation, which is in slope-intercept form, I know I have a slope of 2/3 and a y-intercept of 0, and this is -3. So I start at 0, -3. I'm going to rise 2, run 3, put a point, and then draw my line through my 2 points. Now sometimes I'm only given my 2 ordered pairs and I have to come up with, well, what's the line that goes to those 2 ordered pairs? I first find my slope. So I'm going to just do 1 minus 3 and 2 minus -2. That gives me -2/4 or -1/2. Again, I'm simplifying my fractions. Now I use my slope and one of those 2 ordered pairs to figure out what's the y-intercept. Doesn't matter which one. I'm going to pick the second one because all the values are positive. And I plug in my slope. I have an x value and a y value, and I solve for my b value, or my y-intercept. So 1 in for y, 2 in for x, -1/2 in for slope. Simplify, add 1 to both sides, so my y-intercept is at 2, or 0, 2. So I have my slope and my y-intercept. I put that together in the equation. Y equals 1/2 x plus 2. And if I want to verify that, I can start by graphing the line that goes to these 2 points. If I look at that, I'm hitting the y-axis at 2. And if I look at my slope, I go down 1 over 2, down 1 over 2, and I could keep doing that. So there's my slope of negative 1/2. There's my y-intercept at 0, 2. Last thing we'll look at is parallel and perpendicular lines. How do I know if two lines are parallel? Well, they have the same slope, but I have to make sure my equations are in slope-intercept form to compare. With perpendicular lines, my slopes would be opposite reciprocal. So I would have one being the different sign, and it would be the flipped fraction. So remember, I have to have them in slope-intercept form first. So say I want to look at these two different sets of equations, and I want to say, well, which ones are parallel, perpendicular, or maybe they're neither. So this first group, I'm already in slope-intercept form for both of these equations. So I'm going to look at my slope. 2/3 x, 2/3 x, they're identical, and my y-intercepts are different, so that means these lines are parallel. If I graphed them, I could see that they are staying a constant distance apart. Now say I have the second group here. First thing I have to do is change each of those into y-intercept form, or slope-intercept form. So I would move the 2x. That gives me 4y equals negative 2x plus 4. And now I need to divide every term by 4 to get y by itself. So y is negative 1/2 x plus 1. I've just simplified that fraction. Now the other one, I'm going to add 2x to both sides. Y equals 2x plus 3. Nothing else needs to be done because that's a positive y. So now I'm going to compare my slopes. I have positive 2x and negative 1/2 x. Well, they're opposite signs, and if I think of this as being 2 over 1, its reciprocal would be 1/2. So they are opposite reciprocals, so they are perpendicular lines. And if I graph them, I could measure that angle that's in between there and see that it is a 90-degree angle.